So we are going to complete now the discussion here. And among the things that we discussed now on our EM wave is that we know its speed. Its speed is 300 million meters per second. And that value no, will only be achieved whenever there is the light wave no, is traveling in air. No? However, if it's not, no, then it may be a little bit lesser than 300 million. No? So in meters per second, that's 300 million meters per second. In kilometers, that's 300,000 kilometers per second. So again, please take note that this is in a vacuum. And there are media like air, water, glass, no? Where light can also travel. And again, the value there may be lesser than 300 million no, meters per second. So light will most likely travel slower no, in medium other than vacuum. Now, we will go back to this knowledge now when we go into the discussion on, or maybe now when we talk about the theory of special relativity, no, which gives importance now on this speed of light, no, and its relevance. And again, the claim that this is the fastest speed in the universe. Now, aside from that, now we have also varied wavelengths and frequencies for the given light. So the visible light, no, we can see its varied colors from red up to violet because of the changing frequency. Now, if we base it in terms of the wavelength, then it's between 400 to 700 nanometer. No? And perhaps that wavelength now may probably be when electromagnetic wave no, or light is moving in a vacuum as well. Now that wavelength or probably the speed may change once it passes through varied mediums. And we call that change in the speed and the bending of light as refraction, which we are going to give a meaning when we go to the next lesson also. Now next, we have again these different wavelengths. So this is the range of wavelength of the visible light. Again, the visible light is only a tiny part of this long spectrum of electromagnetic wave. And ang ina nga very small, seemingly a very small part of this extensive spectrum of electromagnetic wave. This one gives energy to the Earth roughly at around 40%. So the visible light is providing the Earth with 40% of heat. Kung wala niyang visible light, most likely the Earth will be a very cold place to live. Now likewise, this visible light, once it also penetrates water, it can only penetrate the ocean at around a depth of 200 meters. So from the water surface to a depth of 200 meters, we believe that that is still filled with light. So planktons and other aquatic life that depends on the sun for its food can still manufacture their food. Like again, plants or planktons in the water within that depth. Now between 200 to 1,000 meters, the amount of light there will become reduced. So the intensity of light becomes dimmer and dimmer as you go beyond the 200-meter depth of the ocean. So from the water surface going below 200, then it starts to darken already. Now beyond 1,000 meters, or that's 1 kilometer below the water surface of the ocean, then it's complete darkness. So it's already very, very dark. And again, because of light dispersing and it could not penetrate the water, that the only thing that is visible on this level below 1,000 meters are the bioluminescent creatures. So if they are fishes or other aquatic life, they provide light underneath the ocean, no? Because of their bioluminescent nature. No? So, but again, this light is providing us not only light, but even heat. No? So 40% of the heat or more is provided by this range of light. No? Now, in seeing colors, no, so we see a red color when a beam of light now, which we believe to contain at least 7 varied colors. No? So we shorten them in an acronym called ROIG-BIV: red, orange, yellow, green, blue, indigo, violet. No? Now, with this range of color, we could see that a red color could be seen by your eye once that 7 varied colors strike the surface, and only red will bounce back or reflect. So whatever is the color of the surface, that's the color that will bounce back or reflect. And then therefore, once this one goes into our eye, we perceive it as a fruit colored red, or maybe this is a red apple. No? Now green is the same way. No? So we see a green colored pepper. Now this is a bell pepper, and we see it as green because green is the one that is reflected back by the surface of this bell pepper. Now, in case all the light, all the colors of the light reflect back, all of them reflects back. Now, the surface again will appear white. White is a color of something that does not absorb any of the 7 colors, at least 7 colors of the visible light. Now, when all the 7 colors, on the other hand, are absorbed, now the surface appears to be black in color. So we believe black absorbs all the photons, and therefore it appears completely black. We coined the word black hole in the universe to be black hole because we could not view them in the sky because every available light is absorbed by the black hole. Since nothing returns back to us, we won't be able to detect it with our eye. So I believe if we want to find the black hole, if it is there, then we have to find it by other means, not by visual or using our eye. Because we can only see things when the light from that object goes to our eye. Now, if you're also familiar with driving, if you drive at night, you will always observe that when you open your headlight, the road would seem to appear as if it's always black. When basically it's literally black. Now, especially if it's asphalt, you'll notice that the road, even though you have a very bright light there, that the road would seem to have no light. It's as if you are not using any headlight at all. Because again, the road being black never reflects anything back to our eye. So that's the illusion that we see whenever we are driving, as if we are not using at all any headlight. Okay. Now next we have this thing about materials that are transparent. Now, of course, transparent are materials that light can pass through readily. So it can easily be penetrated by light. Now, translucent are those where light cannot directly go into it, but probably are bended. And maybe on the other side of this material, you can see a silhouette of somebody being there, but you could not recognize their faces. So you know that something is moving there, but again, you could not identify what it is. So that's a translucent material. So light can pass through vaguely, and again we could not recognize anything beyond that because it's not clear as a clear glass. Now when the surface never allows light to go through it, then we call the surface to be opaque. So opaque are materials that never permit light to get through them. So here are some short ways to describe each of those things. So transparent, translucent, and an opaque material. Now reflection is possible, and again, the importance of reflection, especially in mirrors, is that we are able to see an image in a mirror. It's because of the idea of reflection. When light strikes a surface, then we realize that once it goes to your eye, then you are able to perceive them. So every material, like a wall, like a curtain, they are not naturally producing light, but we know that they emit some amounts of light, either their own or reflected light, because we see them. So you see a curtain that is orange, you see a wall that is beige, because again, they bounce back light. If you cannot see them, then most likely, they are probably black in color, because nothing is being returned back to you. Okay, so again, I believe also it could be also much more safer if your car is not black, and especially when you're driving at night, so maybe a car that has a black paint probably would less likely be seen at night, because again, it does not reflect a huge amount of light, so that you can notice it. So again, something about color. Now A and B, we see some regular reflections here, whereas now on letter B, the nature of the incoming light or incident light are regularly spaced. However, when they are reflected back, they are now going in several directions. So one thing that we can see in letter B versus letter A is that letter B is a very irregular surface. This is a ragged surface. Letter A is a smooth, flat surface. So mirrors are basically usually flat. So you don't use a mirror that is ragged, because maybe you will not really appear as what you would want to see on the mirror, if your mirror is irregular in its surface. Now there are some stickers, there are some devices that are used as reflectors. Those of you who are fond or are into you ride your bike on weekends, on afternoons or evenings, then maybe you protect yourself by putting some reflectorized materials. Now you'll notice that if you examine the reflector that you are using, they are probably not designed to have an even or uneven or flat surface. So you will probably notice that they are purposely made rough or irregular. So when they reflect, then you could really notice something in that surface that goes to your eye and catches your attention. So like some parts of a tail light of a vehicle, those reflectors again that are used by motorcycle riders, and many others. So the surface there is basically made irregularly uneven. So so that it can reflect a much intense amount of light. So again, a rough surface versus a smooth surface, and how the reflection is coming out of our surface. Now there are things that we can see probably in a reflection. So our reflection, it will involve probably two things. One, you can have your one thing, you can have your angles. So first of all, here you could have your angles. So again, continuing here, so in reflection, we see that we will be involved. What will be involved are basically angles and lines, no? And starting with the angle, no? So what are we referring to as angles here? So on this one, no? So you have here a line, no? We call this as the incident ray. Then this one, no, is the reflected ray. And they are always, no, in terms of a certain angle, they form an angle, no, with respect to this vertical line called the normal or the normal line. So basically, you know, there are three lines here: incident ray, this one that strikes the surface, the one that reflects back, no, or returns upward is known as the reflected ray. And lastly, you know, this vertical line known as the normal line. Now, from the normal line going left, you have your letter I. No? Letter I is an angle that we will call as the incident angle of incidence. Now, from the center, no, from the normal line going right, we now have an angle that is formed from the normal line to the reflected ray. And we can call this with letter R. No? So again, now what are the relationships of these angles and these lines, no, with one another? And how are they related to our reflection? Now, in terms of the law of reflection, this is what we know, no, about this law of reflection. And the significance of the law of reflection is, of course, no, in identifying an image that we see, no, in a given mirror, or how, no, a surface probably, no, will emit, no, the intensity of a light or the reflection of a light. No? Now, the first of this rule, no, or of this principle of the law of reflection is that the angle of incidence, or I, no, small letter I, is equals to your angle of reflection. So whenever reflection happens, I and R, no, have an equal value. So that's the first principle. No? So if the surface is irregular and not flat, then you have to consider now where to put the vertical line or the normal line. No? This normal line is always perpendicular to the surface that you have. So it is not always, no, directly pointed upward. No? Depending on how flat, no, is the surface that you're considering. No? Now the second principle in this law of reflection is that, no, these three lines that we identified, no, so the incident ray, no, the normal line, no, which is the vertical line that you're seeing there, and the reflected ray, no, they are now in the same, they are now, no, located in the same plane, or they are called coplanar lines. They fall in that same line. No? So again, no, this is our, no, concept or summary, no, of our law of reflection. No? Regardless of whatever is the shape or the direction of the normal line. No? But the incident ray and the measurement, no, of that reflected ray will always be based, no, on how much, no, is the angle of I, no, or the angle of incidence. Okay, so these are, no, our summary of the law of reflection. Now look at how the surface now changes, or how the reflection now changes whenever the surface is now slopey. No? There's now an angle or slope on the surface and it is not horizontal anymore. No? So if it's horizontal, then maybe now we will see the same thing. No? Now look at how the incident ray are coming. You know, they are regular, no, in pattern, same position. No? However, how they reflect is always based on the normal line. So if the normal line now tilts, no, then therefore your reflection will now increase in value also, no, so that the angle of incidence and the angle of reflection will always be maintained. No? And therefore, look at how the reflected lights now are going. So they are not anymore, no, in a regular pattern, no, like the flat surface. Okay, and then that's the conclusion, no, of